let's kick it off. Welcome to Serverless Java with Spring. Glad that you are still around. We know it's exhausting to consume so much of content, but we hope there's something new for you in today. My name is Kieselhorst. I'm a solutions architect at AWS in Germany, and I do the talk together with Max, who will cover also the first half, and I'll be back for the second half of the session.
Yeah, thank you, Dennis. Yeah, welcome everyone. My name is Maximilian Schellhorn. I'm a senior solutions architect with AWS. So I'm based in Innsbruck, Austria, if there are any Austrian here in this talk. And yeah, Dennis and I, we're working quite a lot with customers on helping them in their cloud journey. So working with Java and a lot of serverless Java. And we have helped them over the last couple of years, and we want to share some knowledge that we gathered over this last 2 to 3 years and share it with you today. So we'll start off a bit with the fundamentals. What is the motivation behind serverless Java in general? How can we leverage the Spring ecosystem to develop efficient serverless Java applications? And then we will look also into performance considerations. So let's start off with recapping a bit what we call a server-based application traditionally. So over the last couple of years, we've seen a lot of movement in containers, obviously, because it makes that much more resource efficient, because they share the underlying operating system's kernel, and therefore we can put a lot more containers on a single machine. So we have our container, usually, that has multiple dependencies. So we have a base image, we have our runtime like the Java, JDK, JVM that we're using, and the Spring framework with an embedded HTTP server, for example, if we build a web application, and our application code. Now the container itself usually needs to put somewhere. It needs to run on a compute node where we have our container runtime. I can have the runtime locally and on-prem or in the cloud, and that makes my container portable. And then usually a single container usually does not live in isolation. So I have multiple instances running for high availability. I might have multiple different services, an order service, an invoice service. So I need some form of orchestration to be able to also shift the traffic between the different services and route it accordingly. And a container without anything else is usually pretty useless. So I usually talk to some form of other system or component inside a network, be it like I have maybe an application that reads something from a Kafka cluster or from RabbitMQ, or talks to another downstream service. So usually containers don't live in isolation. And I think this has been production proofed and the industry standard, and a lot of evolutions have happened over the last couple of years in that space. However, it also comes with a couple of implications, right? First of all, I need to manage all those components that we see here on that picture. And if we look a bit on the scaling side, I think this is also a very familiar paradigm for us. We usually initialize our container once, so we pull the image, start up the Spring application context, for example, and then I have a running application that can do multiple things, handle multiple requests at the same time, might have a background task that is running or constantly pulling from somewhere, or exposing HTTP functionality to be there to be able to accept traffic. Now I said that setup that I think we all take for granted has a couple of implications. On the good side of the implications, it's a very familiar environment for us. A lot of open source tooling around that. I think a lot of talks also at that conference covered the variety of optimizations and things you can do with containers. You have a lot of control. You can SSH into the underlying instances, and you have all the debug capabilities that you expect, and a lot of flexibility. So I can run containers on a specific and dedicated hardware that has GPUs, a dedicated amount of RAM, CPU architectures, so I'm very flexible in where I put my applications. However, there might be also some challenges or things we take for granted that we maybe could do a little bit better. So if we think about the nature of a container, it's usually long running. So even after it's processed its request, it usually stays there to be able to expose that HTTP connection, for example. So even though it's not processing maybe any requests, I still need to pay for that also from the billing perspective. And it also is a coarse granular scaling if you think about it entirely. Let's say we have a container that can handle 100 requests at the same time. If I get the 101st request, I would need to spin up a whole new container just to accommodate that additional requests. Obviously, the scaling mechanisms are a bit more nuanced, so I scale on CPU or memory, but in general, I always have a bucket of a request that I can handle with a single container, and if one thing spills over, I need that new bucket. So maybe we could optimize that a little bit. And last but not least, all the things that we have seen so far, we've seen that we have a lot of things that we need to take responsibility on, right? So we need to take care of the networking, of the compute, of the auto-scaling, how also a Kubernetes cluster behaves, how it scales. I need to do cluster upgrades. So there are quite some operations and management tasks I need to take care of, and sometimes companies even have their own dedicated teams just to make sure that the underlying container environment keeps running. So the question is, can serverless help here in that case, or what can we do better in that scenario? And the promise is mainly 4 things. So first, we want to reduce our operational overhead. All the things that we have seen to manage, can we reduce that somehow? Second, we want to have automatic and fine granular scaling as good as possible, so really scale on the unit of consumption that we need. The third one, we then also only want to pay for that unit of consumption that we scale for when we are actually processing a request. So instead of having an HTTP server exposed 24/7 that we need to pay for, we just want to, in an ideal world, only pay for the actual request processing. And last but not least, since we take a lot of this responsibility to someone else, we expect that environment to be highly available. So when we run our code, it should run in multiple different data centers or locations, and also should be secure by design. So what does serverless maybe not mean? Serverless doesn't mean there are no servers anymore. Actually, there are a lot of servers behind serverless. So this is one of our colleagues, Delin, from the infrastructure delivery team. So you don't need to manage the servers, but Delin has a lot to do with servers still under the hood, right? And now serverless can be more than compute or functions as a service or different container offerings. Usually serverless just means writing applications or services without needing to manage infrastructure. So if you think about something like S3 or SQS or something like that, that's also considered serverless, because for S3, if you're familiar with that, you don't need to have a big rack with a lot of HDD drives or something to store your files. It's really pay as you go, and you just leverage that via an API. So even in a containerized world, we can be more serverless. So this is the traditional setup when we think about managing a container clusters on our own with Kubernetes and maybe EC2 instance, so virtual machines where then the containers are being placed on. So we need to still take care of a couple of things. However, there has been a great evolution in that space as well. So we can reduce that, and for example, with something like Fargate, you could actually take that auto-scaling and managing compute nodes out, and the containers will automatically be placed. You just define your CPU and the memory that you need, and your container will automatically put on nodes, so you don't need to manage a pool of nodes anywhere, and you don't need to upgrade them and patch them. Everything will be taken for you. And we can take that step even further. So as an example, we have also a service called App Runner, which even takes that networking aspect out, so that you just put the container in. If it doesn't need any networking component, you can even run now the container image with very little overhead. However, we thought today, I think there have been a couple of talks on container optimizations and CRAG and native image and app CDS and everything like that. So we thought, let's maybe, if we are all in that container world for the last couple of years, let's maybe try to look a bit behind containers today. So we want to basically give you a bit of an outlook what you can do maybe with functions. So can we be even maybe a little bit more serverless with functions, or what does functions offer us? Or what is the unique value proposition of functions? So with functions, first of all, we can reduce our stack that we need to manage or care of even a bit further. So the promise of function is that I usually only write code, or my function, so to say, and everything else is being taken care of. So even the runtime environment, such as Java 21 or any Java version, is taken care of, and you just drop your code, your uberjar or zip file, and you drop it somewhere, and it should be run in an optimal way. So what does a function mean? So function is really just a simple Java function, for example, and it has three main components. So first of all, the function itself. It usually gets a context object that has a unique request ID, some context about the overall request, where it comes from. And the most important part is the request event, so the input. As we learn later, functions will always be invoked by something. So, and depending on what that something is, my input argument obviously changes. So I just write that simple Java function, and I define the runtime, like Java 11, 17, or 21. And then you configure a memory between 128 megabytes and 10 gigabytes, and a CPU architecture x86 ARM, and a timeout value up to 15 minutes. And that's all that I can set. So I can set the memory, and the CPU, for example, is allocated proportionally. So I have more of an opinionated way of what I can choose that function for. And as I said, it's very simple. Just package it as an uberjar or in a zip file, and then you handle that over to a service, because we said you don't need to manage that anymore. Someone else needs to manage it, of course, still. So in our case, or as a reference or as an example, we take AWS Lambda. So we just deploy your uberjar to Lambda, and then the service handles all the capacity, the scaling, the patching, the administration of the underlying infrastructure. And there are no servers, for you at least, involved. Dallin still needs to do his job with the servers. And therefore only the function itself is also not sitting there idle until something is happening. Functions usually scale to 0. And that means that what does happen? So how can you scale to 0? So how do you wake up the function when something happens? And this is done because Lambda only the function is only run when you are actually receiving an event. And an event can have different variations. It can be a message that is put on a queue, can be seen as an event, or an API request to an endpoint. Hey, I want to retrieve all my orders. That can be seen as an event. Or if I upload an object to S3 or something, that can also be seen as an event. And only then my function is being executed. And to dive a little bit more deeper, so how does it actually work under the hood? So when we take a simple function, so let's say we just write a function that reacts on an API request, and very simple, it just logs the context ID and then returns back received request with that specific ID. And I want to dive a bit deeper here on how functions work, because sometimes they feel a bit magical. And we say they scale to 0, but obviously functions need to run somewhere, such as the container needs to run on a compute node. The function also needs to run somewhere. And under the hood, this is actually an EC2 bare metal instance where the function runs isolated in a Firecracker micro VM. And I think the most important part to understand is that you don't control that machine or that EC2 instance that is under the hood. So whenever you call an actual function, you're never calling the actual function itself on that node, but you talk to a service that takes care of loading that function there and then invoke it. So you cannot just expose on that EC2 bare metal instance like port 8090 or something like that, right? It's really always invoked with a specific argument from that service. And this is very essential to understand. You don't need an HTTP server in that function anymore. The functionality is always exposed by the service. So you really just need to write the actual code to handle that input event that you receive. And here you see that generically handled via map of string to object, and this is very essential. Now, what is the good part? If we have a service in between, the cool thing is that the service knows how much traffic we get, and therefore also knows on how many functions to scale up. So there's an automatic scaler essentially for you that creates as many functions as are needed to be able to handle those requests. And this is, I think, the most important part when we think about functions is an event-driven integration. So we usually we're integrating a lot with streaming systems nowadays, like Kafka, or messaging with RabbitMQ, SQS. And the cool thing is that the function are very nicely integrated with those messaging systems. And how come? Because the function is not polling itself for getting the actual messages. It's again the service with a concept called event source mapping. And this is very powerful if you think about that. The event source mapping is polling from Kafka or from RabbitMQ, taking the messages, and then invokes your function with the actual messages. And why is that cool? Because you don't need in your function a Kafka client or RabbitMQ client or anything like Spring Cloud Stream or something that pulls from somewhere. All that is done by the service. And if you compare that, what you would do in a container, you would need to set up the client libraries, you need to define a polling mechanisms, you need to see how do I scale based on the queue depth or offset that I am in the topic, but all of that is taken care for you. So depending on the offset that I'm in, the service knows that it needs to scale now the functions behind and can therefore really efficiently scale. Now, when we look about the request handling, so we said scaling to 0, so something obviously needs to happen on the first request. So let's say we just deployed the function and we get the first request. What we need to do is we need to check, is an execution environment ready? This is the micro VM that I just displayed. So is there already a function running? And if not, we need to create that execution environment. And then we would need to download your code, right, that you uploaded to UberJar. We need to start the runtime. We need then to initialize your function code, static initializers, constructors, and only then we can execute the actual function that we have written. And this is what you often hear about when talking about cold starts, right? So obviously something needs to happen on the first invoke, and this is what's considered a cold start. And if we have that being initialized, the next requests, we can actually reuse that already initialized execution environment, and we will be able to be much faster. So this is the difference between a cold start and a warm start. And from a scaling perspective, it now also works a bit different than in a container. So let's say we get the first request, we create the execution environment, we initialize it, we run your code, and then when the second request comes, we can reuse that. And that is just as fast as this would be in a container. So when execution environments are warm, the actual processing of the request is as fast. The only thing that you need to take care of is that one execution environment only handles a single request at a time. So that means if the third request comes while the first one is processing, we create a new VM, we need to initialize that again, and we then execute your code. Okay, this is important to keep in mind. So if you have a lot of high concurrent requests at the very same millisecond, you might experience multiple of those cold starts, but we will learn later on how we can reduce that. Now the good thing is, afterwards we can just reuse that again, and we will be much faster. A benefit maybe of that behavior is that in your code, you only need to deal with a single request. So you don't need to come up with a lot of multi-threading mechanisms and think about concurrency in your single code, because you only ever get a single invoke at the time happening. And this is, or can also be, a benefit in that case. But we wanted to see now how we can develop those functions with Spring. And I think I told you now a lot that how those functions are being invoked. So I said it's not a plain HTTP request that you receive anymore. You actually receive always a dedicated JSON payload. And that changes. If I get it from an API gateway or a function URL, I get that specific JSON. That is the input argument for my function that I write. And that obviously changes if I implement with Kafka or integrate with Kafka. Then my JSON event looks different. It has obviously informations about the actual messages that are on my topic. And how does Lambda know how to invoke it? So we have the request, the service, our function. This is the same function as before. And we have the class request ID handler and handle request in a generic map string of object. And what I only think that I need to tell the service is, this is the function that you need to invoke when you get a specific request. So I pass in the class and the specific method to invoke that. We provide, with an AWS Lambda Java libs event library, we provide also POJOs so that you can get that input method or input argument already typed as a specific source, like S3 event or API gateway event. However, the Spring ecosystem can really help you a lot in making that whole development easier. And therefore, to write functions in the Spring ecosystem, there is Spring Cloud Function. And that really allows you to leverage the familiar Spring Boot features that you know, like auto configuration, dependency injections. We will see a few examples. And it promotes the implementation of the business logic via actual functions here, so Java functions. And it also does type conversion, so it invokes that. We have seen that raw JSON object. It actually is able to extract a POJO from it, so your business POJO, for example, business object. And it also abstracts you from everything that is specific to AWS. So you could write that function technically with Spring Cloud Function, and you could deploy it to AWS or another function as a service provider, because you're not relying on anything AWS specific, but on a Java function interface and something more that I will talk about in a second. So how does it look like? This is a function written with Spring Cloud Function. So as you can see, we can leverage familiar stuff, right? We can leverage the full Spring ecosystem. We can use dependency injection, Spring data. We can leverage testing mechanisms. And as you see here, we have context agnostic wrappers like message. So I showed you that context object that has unique AWS request IDs. And the message actually wraps that and provides it as a header. So you don't even need to know what AWS context object looks like in that case. And also the function itself. And as you can see here, you're not dealing with the actual API gateway request or something. You actually can get a specific transaction object, which is your POJO. And last but not least, as we've seen, we always need to put like the class that needs to be invoked to tell Lambda which function to call. Spring Cloud Functions provides a generic AWS function invoker. And therefore, usually, if you take that function and run it somewhere else, the only thing you need to change is the actual function invoker. And the function invoker is also pretty smart because it can also do function routing. Because we often get, a lot of times we get asked, okay, I have my current Spring application, I have a CRUD for create, read, update, delete endpoints. Do I now need to create 4 Lambda functions? Will I now have, instead of my monolith, will I have 1,000 Lambda functions? No, the same good design practices also apply to Lambda. So you can, of course, in your same code base, have multiple functions in it. So you can have here a hello function and a hello Spring function. And then you can route and define what specific function you route to. And we will see an example in the next slide, but the cool thing is that the Spring Cloud Function environment also allows you to expose that function locally. So you can do Maven Spring Boot run, you bring up the application and exposes the functions via an HTTP endpoint. So you could do curl localhost hello or hello Spring, and you can just test it locally as you're being used to. And you can even leverage the Spring integration testing libraries to test those endpoints. So this is pretty convenient and pretty cool and allows you also to keep your local environment as you are used to it. And the routing aspect, as I said, is also quite cool because we now have that generic function invoker, but let's say we have 3 functions, MySpring function 1, 2, and 3. And we want to, depending on the request, invoke a specific function. We can provide that with an HTTP header when we call the Lambda function or an environment variable. And then depending on that, the function invoker knows, okay, now I will call that specific function. You're quite flexible here with the function invoker. So let's recap. This functional approach of writing the Java code for Lambda, for example, like really working with Java functions, is the standard way when you think about handling events from Kafka. As we said, we always get that input event depending on the source. And for synchronous functions, the cool thing is we don't need an embedded HTTP server anymore. There's no need for Tomcat or anything because we already get the actual event when processing it. However, you might be thinking, I don't want to maybe rewrite everything that I have now to functions, or do I have to do it? What about my good old REST controllers, right? Can I leverage them as well in a serverless environment? And Dennis will share how you can do that more efficient. Thank you.
Yeah, thanks, Max. So this is exactly the steps. You might think now, okay, this is all nice stuff, but I have my existing application. We just did the lift from 2.7 to Spring Boot 3, and now you are asking me to rewrite the whole thing again to just leverage serverless functions? And the answer is no, you don't need to, because you can just keep it as it is. And the answer to this is similar to how our friends from the UK who came here and they want to consume the power out of the Spanish electricity network, they just plug in an adapter, and the adapter makes it work. And this is the pattern that we use here as well. So we plug in an adapter between your existing application and the new world that you have just seen, and the adapter takes care of translating the events so that in the end you again get Java servlet specification requests out of it. And we wrote a library for that, which is called the AWS Serverless Java container. It's an open source library. And basically you get API gateway requests in, and it translates them to Java servlet specification requests. And this allows you to just work again with the REST controllers that you already know, and there are just no modifications required to your existing code base. So you can just again work with HTTP status codes, and they get translated, and you can just add the library to your code, and then you're done. Today we released version 2.0.2, so we made a major lift of the library because of the whole Spring Boot 2.7 to 3 and the Jakarta libraries and the whole namespace conversion that you may be aware of. And this is the latest bug fix release now. It also integrates with the Spring Cloud function library. Yesterday there was the version 4.1.2 released. To get a better understanding on how it works, again, repeating what Max initially introduced to you, on the left-hand side, you see the classic deployment of the Java Spring Boot app, right? You have your Java code, you have the libraries, the Spring Boot library and additional Spring libraries, and you have the embedded Tomcat server. And the Tomcat server exposes a port like 8080, and then you receive the HTTP request on the port, and internally it gets mapped to the HTTP servlet, and Spring implements it, and the dispatcher servlet takes care of routing the requests, right? On the right-hand side, you see the deployment with the adapter. So we have the API gateway, and the API gateway provides the entry point, the ingress to our outside world. But then inside my app, there's no port exposed, but I directly receive a JSON structure, right? And the JSON structure, of course, is something that Spring doesn't understand, because in the classic way, they expect us to deliver a servlet request. And Serverless Java container then does the conversion so that it looks like as if it would be an HTTP servlet request again. And so you can use all the existing libraries and also other libraries that rely on the HTTP servlet specification. If we just turn it a bit around, just to emphasize on the integration with the different Spring libraries. So we worked with Oleg Zurakuski from the Spring Cloud team, and now collaborating a bit closer on how we integrate. So in the past, we just leveraged the plain Spring framework and the Spring Boot application, and nowadays we also leverage elements of Spring Cloud, so we collaborate there together. Which means Serverless Java container does the initial conversion and then delegates it to Spring Cloud function for further handling. And it then leverages the existing Spring Boot and Spring Framework functionalities that you know. For the implementation steps, you just select the library, you add it to your Gradle or your Maven file. Then you configure a handler class because the Lambda service expects you to specify an entry point that basically needs to be the first touch point. And this handler class, you can write your own, but there is one inside the library that you can just configure. And this basically delegates to Spring the Lambda that makes the combination between the Lambda service and, in the end, your Spring main application class. So this is something you configure there, and then you package and deploy it, and that's basically the thing, and you are done. So that's pretty convenient. Advantages, of course, you can keep the controller style. You can easily port your existing applications, and you see the implementation here with the REST controller just stays as is. So that's pretty nice. If we compare it between the way Max described it, so the way of directly writing function code, you have to deserialize the JSON payload or use a library for it. There are no HTTP requests and response classes involved. You can consume and process the content in event-specific code. Sometimes it's nice. Sometimes you may see it as a hassle because it's something new that you need to look into how to do it. But this is the standard way of implementing it for non-HTTP use cases like the SQS or Kafka or asynchronous things that we've seen. It's more difficult to re-platform the existing applications, so it would be quite an effort to rewrite some of the grown Spring applications that you've been investing in to the last years. And there the HTTP adapter is super compelling because it just transforms it, allows you to keep the existing code and reuse it. But there's, of course, some overhead due to the translation, right? So there is some additional logic involved. It's not as plain as a function handler code on the left-hand side. Which brings us to performance as a topic. So this is for Java always a topic that we look into, and the Python and the JavaScript guys always tell us, yeah, you know, I'd rather keep my scripting language and have no JVM involved. So just some values. How long does your Spring Boot app, if you have one, how long does it take to start? 10 seconds? Yeah. And now think about the invocation model that Max described to you. Would it be okay that you have plus 10 seconds for every request? Of course not. And this is a problem that we describe as a cold start, and we want to optimize it. So that's a main issue that some customers have seen in the past, where they said, I can't use Java on serverless functions with Lambda because the cold start just is not affordable. My users, they notice when there's an additional execution environment created, and I don't want that. So, and we see here no optimization. It can even be more than 10 seconds, depending on how much libraries and other stuff you pull into your code base, right? So some optimizations are, of course, just get rid of the libraries. The smaller it is, the less classes you have, the faster we can download the code and start the JVM. But you don't want to write your code without libraries and reinvent everything that you have libraries for, right? So it is a solution, as you see here. No framework makes it pretty fast, but pretty inconvenient. So it's no real solution. Then we have the function handler in the middle, which is slightly faster. There are some optimized dependencies for logging, for example. There's simple logging facility for JSimple, which is smaller and faster for it. But overall, you don't get to, this is in seconds here, you don't get the cold start down significantly. So, and the two things that you see on the left-hand side, Snapstarts and GraalVM, this is what we now dig deeper into. Those are great mechanisms for improving the cold start so that your users no longer notice it. And I'll start with Snapstart. So Snapstart is a feature that we launched to improve the startup performance up to 10 times, depending on the application. How does it work? So we have the micro VM snapshot technology that we use Firecracker for. So Max already told you about Firecracker. Micro VMs, the execution environments, are running as part of Firecracker micro VMs that get started to handle your requests. And we basically take a snapshot of the whole micro VM. So not just the JVM, like Crack does. If you have been to the other talks, it's a whole micro VM, including memory and disk state. And then once the request arrives, we can restore it from a low latency cache. So we create the environment from the initialized JVM, and that's why it's faster. And it's fully managed, so there's no additional hassle for you. You just do the checkbox and say, I want it. And this is how it works again. So the flow is a bit different compared to what Max was showing you earlier. So this step happens already during the deployment. So when you deploy your application to the Lambda service, we create an execution environment, download the code, start the runtime to get a snapshot from it. So we initialize it. There are some hooks called as well. We get to that in a second to see what they are useful for. And then we create the snapshot and store it somewhere. And once the first request arrives, that's something you see down here, we resume from that snapshot. We have the option to call a hook again in your code to notify you, and then we do the execution. And this is much faster. If you see the comparison here, this is, again, dependent on your app, but this is something we did for a typical Spring Boot app. You see that we get it down up to 80%. Which is nice. We've had a full duration of around 1 second there. So, and the cool thing is there's also no additional costs. It's really easy to configure, but there are some things to watch out for. If you think you have something done as part of the initialization, then we take the snapshot and we resume the whole thing from the initialized thing. There are maybe things like a network connection that you already established, and the database closed it because the instance was no longer there, right? It's something, uniqueness can be a problem for encryption if all the snapshots have the same unique ID that you are using, and there may be some other things to watch out for as well. To influence that, we leverage the Crack interface. So if you've been to Jürgen's session where he told you about what Crack is and how Spring supports it, this is something that we are leveraging as well, although it's not Crack that's been used to restore the VM, because we basically snapshot the whole execution environment. You can still use the hooks. And the good thing is that Spring Boot, if you use Spring Boot Greater 3.2, it integrates with Spring Framework 6.1, and there we have the whole implementation of a Crack delegate that takes care of calling the hooks directly and cleaning up the necessary things for you. So, and if you have something in addition, like you want to optimize class loading and pre-calling a certain initializer, you can do that in the before checkpoint method. So just implementing the resource interface from Crack and then do some things there. And same is for after restore. If you think you need to refresh a database connection, then you can do that in this method. So that's something to look for. So lastly, GraalVM. There were a lot of other sessions around here with regards to that topic. Yesterday also Alina spoke about it in the big room. And the message here is really, if Snapshot isn't enough and you want to squeeze out more out of your JVM, then you can move from the JVM runtime to a custom runtime. So you no longer run your Java code on the JVM, but as a binary on a custom runtime with GraalVM. And on Lambda, this works as the following. So you basically create that as you would do with the GraalVM compilation. So that's not something I repeat here, because we had a lot of content already for that. But you just do the build with all the disadvantages that you have heard, like some frameworks do not support it, I can't use certain language features. But assuming you figured all that out, that's why it was a bit more on the right-hand side with regards to complexity. And you have the build done. You add a bootstrap file, and then you deploy the zip to Lambda. And we have a runtime interface client that you can interact with. So even if we have no managed runtime for a certain language, you can just implement your own Lambda runtime using the runtime interface client. And this really allows you to get the lowest memory footprint and improve the startup times significantly. But again, the effort to get that done is just much higher compared to Snapstart. So usually we suggest customers should start with Snapstart, see how that goes. And if you think you need more, then you take a look into GraalVM, because with Snapstart, you can really use all the language features. You still have the managed Java runtime environment. With GraalVM, you just need to take a bit more effort. Good. Additional considerations when running serverless Java with Spring. Some common thing is database connection. We already talked about when using Snapstart. But overall, as the scaling works differently, if you're still using one of the relational databases, you may be using a connection pool, right? So you have your containers there, then there's a connection pool, and connections are being reused. With Lambda, this is working differently. So for every request, you have a different execution environment, which means potentially, if your app scales out and you have many concurrent requests, each of the execution environments will consume an own database connection, right? And some databases, like the newer ones, NoSQL, for example, DynamoDB, it's no problem. But we even have customers who say, yeah, I'm forwarding the request to my legacy database that I have on-prem, and you can easily overload it with such an approach. So things to watch out for is, of course, modify the connection pool configuration as part of your application. Like Hikari is one of the connection pools that's been used. And then we also offer a service, for example, you can plug in RDS proxy in front of the MySQL database, so that it takes care of proxying the connections and doing the pooling. And if nothing works, you can also use reserved concurrency, which means you limit the number of parallel executions that are happening there. So that's one thing to take away. And the other thing is observability. For all the things that I've shown you, it's always important not just to take it away and apply all the techniques because you think it's great. First, you should have metrics and tracing in place to see where you are right now. So is it 10 seconds, 11 seconds, 12 seconds, and what's the requirement? Where do I need to get to? Because otherwise you may be optimizing and optimizing and optimizing, but you should have a goal. Where do I need to be? What's the business requirement? And then with the observability things that you know from your classic environment, it's a bit different on Lambda because there's, for example, no metrics scraping endpoint, or you can't just call Spring actuator on a different port because there are no ports exposed from your Firecracker micro VM. When you are running on Lambda, the observability is done in a push model, which means you push from your Lambda environment the metrics, logs, and traces somewhere else. You can easily achieve that with our services like CloudWatch and X-Ray. So they are integrated. You can enable them with a checkbox. That's fairly easy. But some customers prefer to use open source technologies. And for that, you can use OpenTelemetry, for example. We have an own distribution. The thing to watch out for with Lambda is you need a different layer. And this brings in additional performance considerations because you need to plug in the layer, and the layer has some initializations as well. So that's something to watch out for. Just observability should be a must. You should have metrics, logs, and traces. So something that you should directly integrate in your modernization efforts there as well. Okay, so we knew it's a lot of content. And the easiest way to learn this is by trying it out. So that's why we offer a Lambda workshop. That means you can go there step by step, walk through it. I can just show it to you. We have it here. So there are different modules as part of this workshop. We also run it with customers together. So should you want to run it in your company, you can just approach us. We have a team that is working across Europe, so it should be easy to find someone who runs it with you. But if you are keen to try it out on your own, there's also this tab here where you can just run it in your own AWS account. So you can just register for one. And the module that covers the main aspects that we've shown to you today is the one here on the left, where you find an architecture overview, the unicorn apps that Max and me were using, and then you have all the different steps with the step-by-step manual on how to enable it and to try it out. So that's something that we suggest to get a bit more familiar with it, and once you've deployed one of the applications, it's easier for you to follow what's really going on, and also easy for you to transfer it to your own applications. A second recommendation is the Serverless Java replatforming guide. That's something where we just wrote up again as a summary in a written form on what we've speaking to you about. And with that, I'd like to say thank you, and just a last ask. I know you visit a lot of sessions, but we are very interested in your feedback. So in the Hoover app, there is a session feedback button. If you just press it and provide some feedback, that would be super helpful for us. And now we have 4 minutes left for questions before we head out to the airport.
Hi, thank you for your talk. I have a question. Have you compared the cold startup times between, for example, Node.js and Spring framework? That's it.
Yeah, there's a large open source GitHub library that has all the numbers of comparing different runtimes and how they compare to each other. But what we've seen with Snapshot and other optimizations, we can really get down significantly. So with GraalVM, I've seen times of cold starts even below 500 milliseconds. And this is also depending on an interpreted language or something, then you're almost close to that. Obviously, there are things like Rust or something like that that will always be faster there in that case, but you can, with those techniques, can very significantly get to it. And I think the most important part that we want to emphasize is also, are cold starts really a problem, right? It's for the first few requests, but if the environments are there afterwards, it's really just warm starts. So usually of your production application, the P99.99 requests are usually warm starts. So is that 0 point something really that important to consider? Yeah, so that's always something to keep in mind.
Thank you.
So here's another one up front. Let's wait for the mic.
Then I have a question to the pricing model. So, for example, for Lambda, I think, as far as I know, it's like paid per request.
Yes.
So it means that if you have like a lot of load on your system, you will have to think about, is it really good to use Lambda or serverless for that kind of application?
Yes.
That's the first question. And the second question is also for the cold and warm starts. If you have a very high load in your system, like even for like kind of 1 hour, that means that you have to think about how many parallel jobs are you allowing, because otherwise it will be all of them, like 90-40% is cold starts, because the number of parallel ones that is not scaled very correctly, right?
Yeah, so the first one on if you say you have very high load and you're constantly hitting the requests on Lambda, I like to compare like also the serverless containers a bit to function in that case. And I like to usually use a car analogy there, right? So I'm very flexible with Lambda, right? I can scale per request. So this is a bit like a car sharing, right? So I can rent 1 car, 2 cars, 3 cars, right? I'm very flexible. If I only reuse that for a couple of minutes a week, or let's say an hour a day or something, right? That can be very cost efficient. But if I need a car 24/7, as you say, right? Then a car sharing might not be a good pricing model, because I don't need all that flexibility, right? So if I need the car 24/7 and I have constant constant usage of it, then having an own car or having like a container is more cost efficient. So that definitely. But we have a 45-minute talk just on comparing containers and functions. We can share also the link with you from YouTube where we talk about those aspects, when also from a financial perspective, maybe would it make more sense to actually have your compute nodes running somewhere to deal with that constant load. So definitely. And I forgot the second question. Yeah. So the good thing is that the execution environments, they usually stay warm for a couple of minutes even, right? So even if the request is processed and that's the only thing that you pay for, the execution environment stays ready for a couple of seconds or even minutes, right? So it doesn't mean that just that the request is essentially gone, that we shut it down and the next one would spill a cold start again. So that means if you get a burst of traffic, yes, the first concurrent request batch might be affected, but afterwards, even if some of the execution environments are not used, they stay warm for a couple of time. So usually the cold starts are not that important anymore. So we always recommend really test production load patterns that you have over, I don't know, a couple of minutes or varying load patterns, right? Because usually we have customers throwing 1,000 requests at the same time at Lambda and saying, oh, I had a lot of cold starts, yeah. But do you have that scenario really in production, right? So load test accordingly and see that was what I meant with the P99.9. Are cold starts then really a problem?
Yeah, and you see the build duration. So there you can really see that's the amount that you've been charged for, and you see that the other duration with the initialization, that's not something that's been charged for. Okay, if you have additional questions, just reach out to us. You can also use the Q&A functionality in the app. Now it's the coffee break before the last session of the conference starts. Thank you very much for attending.